All right, just some more examples of solving logarithms, okay? So we want to use our rules and everything we've learned in order to do this. So right here, you have a log plus a log. They both have the same base, which means this is our product rule, okay? Which we looked at, if you had two things being multiplied, you could separate it into two different logs being added together. Okay, so essentially we're working backwards. So rather than having log base b of m times n equaling log base b of m plus log base b of n, okay, this was our rule. We now have this, and we're going to go to this. Okay, so we're going to keep our common log, our log base 10. We don't have to put the base of 10 when it's base 10. So log of, and then we're going to multiply these two things. 2 times x is 2x equals 1. Now we've combined these two logs into one log. And in order to solve this, I'm going to want to get it in exponential form, okay? So I'm going to put the 10 there just for this purpose. I'm going to start at my base 10, and I'm going to raise it to the first power. And then it's going to equal 2x. Well, 10 to the first power is just 10, so I just have 10 equals 2x. Divide both sides by 2, and we get x equals 5. All right, next example. It's actually the same thing, but instead of just having a 2 or just an x, we have an x plus 6 here. But it's the same rule, log base 4 plus log base 4. You can combine these, so instead of them being added, we're going to multiply. So we would have log base 4 of x times x plus 6 equals 2. So first I want to simplify the inside right here. Okay, x times x plus 6. So we're going to distribute the x to everything in the second set, the x plus 6. So we're going to have log base 4 of x times x is x squared, and x times 6 is 6x equals 2. And now I'll solve. So I'm going to have 4 raised to the second power equals x squared plus 6x. And now I'm going to want to solve, but if I notice I have an x squared, then that means I'm solving quadratics, okay? So I want to get it to 0 equals x squared plus bx plus c. I have my ax squared plus my bx. Now I need to move this 4 squared over here, or simplify my 4 squared. 4 squared is 16. Okay, so I would have 16 equals x squared plus 6x. So I'm going to do minus 16 on both sides. So that I get 0 equals x squared plus 6x minus 16. And then I'm going to factor this, but I'm also going to rewrite it over here where I have more room. So 0 equals x squared plus 6x minus 16. Okay, and then I'm going to do the x box. So my a times my c and my b. 1 times negative 16 is negative 16, and my b is 6. So 1 times 16, 2 times 8, 4 times 4. In order to add up and stay positive, your bigger ones would need to be positive. And the ones that would add together to be 6 would be a negative 2 and a positive 8. So we get x minus 2, and then x plus 8. Okay, so now all I have to do is set each of these things separately equal to 0 and solve. X minus 2 equals 0, and x plus 8 equals 0. So I'd add 2 to both sides, and I get x equals 2 as one of my answers. And then subtract 8 from both sides, and we get x equals a -8 as my second answer. All right, next one. We're gonna look and see what rules we have going on. Once again, we can see right here is the product rule. 2 logs, same base, being added together, so we can multiply these. Over here, I have a 2 out front. So this is our power rule. So power rule said that if I had a log base b of m to power, then I can move that power out front and have p times log base b of m. So that's what's going here. So I'm going to move that 2 back as an exponent on my x. So I'm going to have log of x squared. All I did was move that 2 back to be an exponent on the x. And I'll bring everything down, but I'm going to go ahead and multiply these together. So log of -2 times 3x plus 4. All right. And then I want to go ahead and simplify this. So I'm going to have log of x squared equals log of -2 times 3x is -6x, -2 times 4 is a -8. Okay, now I want to look what I've got. I now have a log on both sides. Okay, log on left, log on the right, they have the same base, which means everything in parentheses should equal each other, right? This log should equal this log, then the inside of parentheses should equal the inside of this parentheses. So that's what we're going to do. We're going to set this x squared equal to this -6x minus 8. And then I end up with an x squared again, which means I'm doing the same thing we did over here with the quadratics. I want it to equal 0 equals ax squared plus bx plus c. Or vice versa. You could have your equal 0 on the right. I just need to keep my x squared positive. So I'm actually going to add 6x to both sides and add an 8 to both sides. So I get x squared plus 6x plus 8 minus -6x plus 6x is 0, -8 plus 8 is 0. So we get equals 0. And now I want to factor that. A times c and my b. So 1 times 8 is 8. And my b is 6. 1 times 8, 2 times 4. So the ones that would multiply to be 8, but add to be 6 would be my 2 and my 4. So I would have x plus 2 and x plus 4. And then I'm going to set each of these equal to 0 separately and solve. So I'm going to have x plus 2 equals 0 and x plus 4 equals 0. Minus 2 on both sides, so we get x equals -2. Minus 4 on both sides, so we get x equals -4. And those would be my 2 answers. All right, last 2. So product rule, once again, they really like the product rule. Okay, you can see 2 logs, same base, being added, which means we can multiply these together. So we would have log base 9 of x minus 5 times x plus 3 equals 1. So I have a binomial times a binomial, and if you remember when we multiply these, we like to use the box method, or you could use the distribution method. So I have x minus 5 times x plus 3. X times x is an x squared. X times 3 is 3x. X times -5 is a -5x. And -5 times 3 is a -15. So we have x squared minus 5x plus 3x minus 15. These 2 middle ones are like terms, which means you can combine them. So x squared and -5x plus 3x is a -2x minus 15. So we get log base 9 of x squared minus 2x minus 15 equals 1. So we are going to use our we only have one log. I don't have a log on this side, so I can't just drop my logs and leave them equal. I only have one log, which means I'm going to convert this into exponential form. So I'm going to start with 9, raised to the first power is going to equal all of this. Okay. Once again, we want 0 to equal ax squared plus bx plus c. Or you could have equal 0 on this side, but we want to keep our x squared positive, so we're just going to bring this over here and make this 0. So minus 9, because 9 to the first power is 9, minus 9. So we get 0 equals x squared minus 2x minus a negative 15 minus 5 is a negative 24. So now we want to factor this. A times c and my b. 1 times negative 24 is negative 24, and b is negative 2. So we have things that multiply to give us 24 would be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. If when you add them together they make a negative, then your larger number is the one that has to be negative. And so we're going to use 4 plus a negative 6 to equal negative 2. So we have x plus 4 and x minus 6. So I set each of these equal to 0. So x plus 4 equals 0, and x minus 6 equals 0. So minus 4 on both sides, and you get x equals a negative 4. And plus 6 on both sides, and you get x equals a positive 6. Okay, so here we have two natural logs that are being subtracted, which means this isn't the product rule. This is our quotient rule. All right, so quotient rule says if you have two things being divided, then you could separate them into two separate logs that are subtracted, okay? So if we have two logs being subtracted, then we can combine them into one log, but they need to be divided with your first one on top. So this would be ln of 3x plus 2 divided by 2 equals 1, okay? I only have one log, this natural log. I don't have another one on the right side where I could cancel them out, right? So what I'm going to do is, we know ln, natural log, is really log base e. So I'm going to take e and raise it to the first power, and it's going to equal this. So I have e to the first equals 3x plus 2 divided by 2. And I'm just going to solve for x. E is a decimal number, but I don't need to worry about that right now. To get x by itself, I'm going to want to cancel out this 2 that's being divided. So the opposite would be to multiply. Okay, so I have 2e equals, these cancel, so 3x plus 2. We're just trying to get x by itself, so I'm going to do minus 2 on both sides. So now I have 2e minus 2 equals 3x. Divide both sides by 3, and that's our answer. X equals 2e minus 2 divided by 3.